Hello. How are you?
Good.
It's been a great show so far. I want to talk about starting where you start in Swift, which is usually by taking Objective-C code, existing code, and just translating it over, and then moving to a place where we introduce these cultures that we know about from the past: object-oriented programming, functional programming, and protocol-oriented programming, and blending that all in. And the example I want to start with is this table view example that you were raised with. And if you open up Xcode and you do the template, well, shame on you. But you start with code that's something like this, where you have a controller, you have a model, you have a view. And so all I've done initially is translate this into Swift. And so I've created my view with a storyboard, as we do. And for the model, I'm going to use a deck of cards and deal out 5 cards, and I'll call that my hand. And so a deck of cards, my hand has rank and suits, and so I'll represent those somehow. And now I have to manage that model and that view with the controller, and I'm going to use a hand view controller, which is a subclass of UI table view controller. We're just going to start very typically the way we all do. And what you can see here is, unfortunately, the view controller knows a lot about the model, and that's not a good thing. So we're going to start pulling information out and refactoring the view controller to see what we can do with this situation. But first, I went to great difficulty to design this app for you, so I want to show it to you. We can hit the plus button to deal cards. Well, thank you. We can delete cards, and we can move them around. And so that's my app. You can put it on the store. So let's look at the code. Let's start with the view controller. And my controller class is this hand view controller, which I call hand VC. And it is a subclass of UI table view controller. And one of the things I love so much about Swift is this is how we have a property. None of this declaring it somewhere and initializing it somewhere else. We just say, there's my property, and so the view controller knows about the model. And then when I push the plus button, this method is called, and my action is add new card. And so I have this condition: if we have fewer than 5 cards, then we're allowed to add one more. And we add another card, as always, by first adding to the model, and then adding to the view. So this should be very familiar. I tend to take this code and pull it out for the view so that I extract it into a separate method like this. And so my action is very simple. I see that it's model and then view, and I pull out the view code. And you're going to see that later this allows us to pull this method somewhere else. So very short methods. Is that what you do? Yes, we do. Okay. And so here I am in my hand view controller, and these are our 2 table view data source methods. This first one figures out how many rows are there in the section, and it does it by turning to the model and saying, hey model, how many cards do you have? And the other one is used to fill in the table view, and so for each row in the table view, we fill each cell, and we get the corresponding model object. And then we set the rank and the color. And then we display the suit, and again, nothing fancy going on here. This is the world that we know already. And now if it's time for us to delete a card, we implement this method, and just as when we added, we delete from the model, and then we delete from the view. And as always, I like to pull that line out, and so I extract that code. So we delete from the model, we delete from the view, and we put that deleting from the view code in a separate function, and notice it's private, because that's nobody's business, okay? To move a row, we don't have to do the GUI code. Apple does that for us. All we have to do is take our model code and go ahead and say, here's where I'm moving the card from and to. And this is our view controller, and notice each one of these methods in the view controller turns and talks to the model. And so let's look at the model and see how the model is implemented. So here's our model. It's a hand. The hand has a deck of cards that it deals from. Now, the model is right now a class. And you might notice that when we come to Swift, we're taught that, oh, classes are bad, we should do everything in structs. And we will change this to a struct in a while, but we're starting with sort of an Objective-C mindset. So we started with the class, and we'll move it over, and our class, our hand class, has a deck of cards, and then it keeps your hand in an array that holds items of type card. In order to back up those methods that fill the table view, I need to know how many cards there are and what card is at this position. I do the first one with a computed property. Love computed properties. I do the second one with a method that returns the card. And so I know which card is at a given position. We can support our table view data source. Okay? And now we need the methods that support adding, deleting, and moving cards. So, this is familiar to everybody? And you would stop here and be happy. And I would forgive you. But Swift is moving and we need to move with it. Think about it this way. When Swift was introduced, we didn't know the right way to do things in Swift because no one knew the right way. The community is sort of learning together and trying these things. So what I'm going to do in the next 20 minutes is talk to you about some ways that we can push this example. And the purpose is not to say that this will be the best way to implement a table view situation. It's just to say, here are some tools that are available to us. Here's some things that you can try. And this is just an example of how you might do it. So the first thing I want to do is I want to change that model view class from being a class to being a struct. So to be more Swift-like, instead of being a reference type, it's going to be a value type. And we can keep better track of what changes in an app by saying, oh, reference types, more than one thing can be pointing at it, and so more than one thing can be changing it. With a value type, that can't happen to us. And so I'm going to change my hand from being a class to being a struct. Unfortunately, if you have a struct, all those methods that change the value of properties, they now have to be mutating. Now, not only do they have to be mutating, but the hand variable that we set in the view controller now has to be a var because it's changing. That's different with structs and with classes. If hand were still a class and we changed its properties, hand could still be a let, and its properties could change out from under it. But with value semantics, hand itself has to be a var as well. So the next thing I'm going to do is I'm going to eliminate mutating. And there is nothing wrong with mutating. You know what I mean. Apple has made this clear. One of the really nice things about the Swift evolution list is the engineers that are working on Swift itself weigh in, and not only do they talk about what's coming, but they give you reasons for why they've done certain things. And people were pushing back about mutating, and recently on the list, they said, you know, our issue isn't mutating, our issue is shared objects. Our issue is more reference types than that something could change from under you. But I'm going to eliminate mutating in an effort to make this more functional. It's the fun and functional that we're after. And so we're going to get rid of mutating, but if we're no longer changing the value of hand, then these methods have to return a new instance of hand. And so add new card now returns a new instance of hand. Add new card is using insert card. And so insert card, our private method, it too must no longer be mutating, but return a new instance of hand. And it's the typical thing we're going to do when we get rid of mutating. We're going to create a local mutable copy of our immutable cards, our immutable array. We're going to change that by inserting the card we're adding to the array. And then we're going to create a new instance of hand that uses the same deck we've been using, but uses this new mutable array that we've added the card to. And so that's how we'll add. And so if we're adding and we're changing hand, then we have to go back to the view controller. And the view controller has to store this new value. So I have to assign hand to be this new instance of hand. Okay? Instead of it being a class that changes or a mutating object that changes, I have to say, assign this new instance of hand back to my hand variable. And so that's what I'll do when I add a new card. I'll do the same exact thing when I delete a card. I'll do the same exact thing when I move two cards. So in each case, I have to assign the new value back to hand. Whew. Let's go back to our model and see what delete looks like. Delete does the same thing that add did. We create a mutable local copy. We change our mutable local copy, and then we create a new instance of hand with the same deck, but the cards that have that element deleted, and that's what we return. And so that's what delete looks like. So add and delete look very parallel. Move is different. And this is what made me fall in love with functional code. This is just so cool to me. Move is different. So let's start with the non-functional version. So the non-functional version looks a lot like when you have to swap two things in an array in Objective-C. You have to store one of them somewhere else, do the swap, and then take the one you set aside. So here, we take the card that we're moving and we store it somewhere temporarily. And then we delete that card. And now we insert the card that we saved back into the new position. So that's the non-functional way. There's nothing wrong with that. We've done it for years that way. Past code review and everything. But here's the functional approach. With the functional approach, I have this move card that's going to return a new instance of hand. It is still going to use delete card at index and insert card. It's still using those two methods, but notice it changed them together with that dot. That dot means we're going to delete the card. That's going to give us a new instance of hand, and then we're going to ask that instance of hand to insert a card. We're not saving anything anywhere. Why not? Because delete card at index doesn't change our current set of cards. It creates a new hand. Our current set of cards still exists. So I create this new hand, and then I ask that new hand, hey, can you insert a card? And it says, well, what card? Fortunately, we still have our set of cards, and we say, this card. So if this doesn't make you smile, you can go back to Ruby, Java. So we've returned our deleted card. We've done a functional version of moving a card. We're feeling good about ourselves. Let's push this example in another direction by changing the way our UI looks by making a custom cell. And so we'll customize our storyboard, and we'll create a class that backs it up. And so I'm going to create a new look. And so here's my new and improved look, where you're just selling look 1. Ooh, I can add. I know, my UI skills are just amazing. Okay, so that's what our new app looks like. It does exactly the same thing, but it allows us to think about creating the custom cell that backs that up. And so our custom cell is going to be called card cell. Card cell is a subclass of UI table view cell. So you're often reaching for classes when you have to work in the UI kit hierarchy because you want to get the behavior that you inherit for free. Our UI table view cell feels like it should be view code, but I find when I write code for these things, it's really controller code. I'm doing the view stuff in the storyboard, and even though this is inside the custom card cell class, the code that I write here is more controller code. And so I need to be able to talk to my two labels, the one that holds the suit and the one that holds the rank. And what we're using is sort of a modified model view view model. I don't even know what that means. And at first it looks like things have gotten worse because our hand view controller has to talk to the table view and it has to talk to the custom cell. And you see by my little icons that everybody seems to know about the model. But it's darkest before the dawn. This is going to get better. Okay? So here inside of my custom cell is a fill with method. And so this is the cell, and the view controller is going to say, because remember, the controller's job is to talk to the model and to the view. The controller is going to say to this object, here's the card you're being filled with. I want you to take this card and I want you to draw the rank and the suit in the right colors. And so this card cell knows how to fill the cells. And so now my view controller has to say, well, I have to make sure that I'm talking to the right type of cell object. And so inside of a guardlet, and we all love guardlet, inside of a guardlet, all I'm doing when I DQ my reusable cell is I'm making sure that it is a cell of the right type, that it can be filled with these things. It's a card cell. If not, we get a fatal error. That will never happen to us. But what's nice about this fatal error is this should come up at development time, not at deployment time. So it tells us as we're developing, is there a problem? If it is the right sort of card, then I turn to that cell and I say, fill with, and I hand it the model object. Now, this is a little small thing, but that code looks long and gunky, and I have to read through it and see what card at position means. And so if you go back over to your model and you implement a subscript, you can simplify the look of that code a little bit from being this to being this. And that looks nicer. I'm filling with this element of the hand. And I can see that this maps over really nicely. So if you're not using subscript, this is a nice place to reach for it. So ordinarily, we take a nap at this point, but we have short time. So we're going to go on and push this in another direction. And I'm going to take the data source out of the table view controller. Just because UI table view controller comes and it automatically comes with the template where it's implementing the UI table view data source and UI table view delegate, you don't have to leave it there. So we're going to take the data source out of the table view controller like this. And you can sort of see that we've got these things in the top row that don't know anything about the model. And we're going to start pulling more things out and isolate what things know about the model so that at some point we have some sort of a design where if you don't want to use this table view to show deck of cards, you can use it to show anything else. We're going to isolate the code that changes from the code that doesn't change. So if I look at my data source is a subclass of NS object that conforms to the protocol UI table view data source. Unfortunately, it must be a subclass of NS object to do what we need to do. It can't be a base class. It can't be a struct. It has the handle to the model object, so that's how we've pushed our knowledge of the model down. And all of these methods we push down as well. These are the methods that used to be in the table view, and now they've been table view controller, and now we push it down here to our data source, and we're feeling pretty good. All this stuff is down here. It runs perfectly just as it used to. If we look at our view controller, there's not a lot left there. There's a handle to the data source because it needs to pass things on. We set our table views data source here in our view did load. And the only other thing we do is when someone hits the plus button, we pass that message on to our data source. And the only other thing you should notice is we also have to remind the data source who its table view is. Because we are connected to the table view at this level, but the data source isn't. So we have to pass that in as a parameter. But the nice thing is now if we look back at our data source, every one of these methods accepts a table view. So it just needs to know what table view it's talking to. Now the bottom two methods are where we pulled out our visual code. So the bottom two methods are a little different, and so I want to introduce a protocol and I want to pull them out of here. You just pushed them down here. Now you're pulling them up. Yes, but we're pulling them up somewhere different. So let's introduce a protocol. I'm going to call it source type. You liking this diagram? It's almost as good as my app. So I'm going to pull that GUI code, that visual code up to my source type. And here's my protocol source type. And it conforms to my UI table view data source. And it holds my visual methods. So I declare them here. And it's a protocol extension. Thank goodness for Swift 2, where we got to actually implement these methods. And so inside of my extension for this protocol, I can implement these methods. Now, I have my data source. It is a subclass of NS object. It conforms to UI table view data source, and it conforms to source type now. And since it conforms to the protocol, I'm now getting all the behavior I had before. Now, I'm a little bit worried that I have this word card everywhere. It seems to spread this news of my model object too far. And so I want to look inside of hand.swift, and everywhere I use the word card, I want to replace it with the word item. Okay? And now that I've taken the model out of here, I can capture this in a protocol. Oh, enough with the protocols. Oh no. And so in a protocol called data type, I'm going to capture that, and I'm going to pull up all those public methods, and this is wonderful, because if you look at data type, it captures all of the things that my model has to do. My model has to be able to tell the table view data source how many items it has. It has to be able to add items. It has to be able to delete items, and it has to be able to move items. So this protocol does what protocols are supposed to do, and it says, here's what this sort of thing, here's what this type of thing has to be able to support. And so once I have my data types, I have to use this one little trick that we have in protocols, which is these things used to return hand, they now have to return self. And so if hand conforms to the protocol, they will return hand. If instead it's lunch boxes, they'll return lunch boxes. Whatever they are, whatever is conforming to data type will return one of themselves back. And so we capture that with self. Well, set hand to conform to the data type method. And now I've declared all these methods. I just implement them here. But because I've conformed to this, I can use data type. And so instead of source type knowing about hand, instead of data source knowing about hand, they can all talk to a data type instead. And so I can eliminate hand throughout my code base. And so in my source type.swift, I have a data object, which is a data type. Well, in the case of a hand, that's just going to be a hand. I declare that it has a getter and it has a setter. And so in my data source.swift, my data object is going to be an element of type hand. Still doing okay? You can say stop. Okay. And so when it's time to add an item in my data source, if I have fewer than 5 items, wait a minute, should that really be here? Should that knowledge be? We'll fix that later. But if I have fewer than 5 items, then I'm going to tell my data source to go ahead and add a new item and add it at the top. And so instead of using the word card, we've used the word item. I add a new item at index 0. Again, I know that my type of cell is the right type because we tested for that earlier. We also add to our guardlet a second check to make sure that the data object I get back is actually an element of type hand. Because before I try to fill that type of cell with this type of model, I have to make sure that it's the right type of cell and the right type of model. And so this guardlet checks both, and if they both pass, then I go ahead and fill the data. I'm having so much fun that I look to see what else I can pull out of the data source. And so I look at this add item to, and if I only didn't have this line, I could pull it out. But I remember from design patterns, we have the template pattern. And the template pattern allows us to do something and then go down to the specific case and then to come back up and finish it. And so here in my source type, I can add a computed property called condition for adding. And my condition for adding could be specifically implemented at, are the number of items less than 5? But what that allows me to do is go back to my source type, and in my extension, I can use this condition for adding inside add item to because it's declared in the protocol. Every element must have this condition for adding. Now, I'd love to move everything else up into the protocol too. but I can't. And at this point, you might get angry because you've forgotten, we've done so much Swift, we've forgotten that we can still introduce subclasses. We're allowed to do that. I know they're a little bad, but we can do that when appropriate. And so if we have this now, and we introduce a subclass of data source, and we push all of our code down that needs to be pushed down, my hand data source extends data source. And so in my hand view controller, I need to be able to create an instance of my subclass. And now I push all my hand references down into the subclass. And I have to do that by overriding my condition for adding. So I'm going to have to stub that out in the superclass. And I override my table view, so I'll have to stub that out in the superclass. And so what does that look like in the superclass? If you ask me, can I add something, I'm going to stub it out as no, you can't. So unless you subclass and tell me what the condition is for adding, I'm going to say by default, no, you can't. And for the table view, if you don't override it, I'm going to throw a fatal error. So you have to override these two methods to get anything done. So how do I create an instance of these guys? I've got my data object, which is a data type, and so I have to initialize it, and I've gone 24 minutes without generics. I feel pretty good. But I have to introduce generics too, because what we're going to initialize has to be of type data type, and so as you've seen from other talks today, I have to do it this way, where I specify that your data object can be any class as long as it conforms to the data type. And then my actual init here calls superinit and passes in a hand object, and hand object conforms to data type. So now we need a moment to reflect. This is a picture my wife and I took in Kyoto yesterday. It snowed. Check that out. Which is not what I want you to reflect on. I want you to think about what we've done. We started with a table view, and we ended up with code that might seem more complicated, but really we've simplified this in many ways. What we've done is we've factored out the code that doesn't change. That's all this stuff at the top. This is reusable in any table view that you handle. Not saying you should, you have to, you must do it this way, but just showing you how we push things around. And what's left is the code that does change, and that's here at the bottom. These are the only things that you have to change for different sorts of table views. And we did this by taking advantage of these three worlds. So don't just tie yourself in and say, I only do objects, I only do functional, I only do protocols. You've got these three wonderful tools, and you live at the union of them, not at the intersection, not in any one of them. Thank you.